Hello, everyone. So we'll be starting in 5 minutes, as usual.
Hello Alex.
Hi, Pascal. So it's 5 minutes past the hour, and yes. So Pascal, if you can go ahead and do the honors.
Okay, fine. Hello everyone. So this is an official IETF meeting. It's a SCHC interim meeting. So you're welcome to attend and discuss every topic that's being discussed today. But please keep in mind that we have to follow the IETF process, and in particular, if you're aware of any IPR about something that is being discussed, you have to announce this IPR or refrain from talking about it. So, well, with this, people here are well aware of the behaviors, procedures, so no harassment, kind discussions, open discussions. That's the usual IETF behavior. So the agenda for today, we have received several requests to propose new work. So we have in particular, Marion was proposed a context life cycle discussion. There is a typo in the quick compression URL, sorry for that. And after that, so Samar will present first the quick compression, then Marion will discuss the SCHC context life cycle. And finally, Laurent will update us on CoreConf for SCHC, this new document that he has also published. So a lot of new work. We're very happy to see all this activity on our mailing list in our working group. So actions. Alex, submit INR request for SIDS. Hello?
Yes, hello. Oh, it's strange. There used to be checkboxes here of the things that we actually did. They do not appear here.
Yeah.
So a lot of the things are done. Like the first like submitted IANA request for SIDS, that's done, and we'll discuss it like in a minute on the next slide. We did request a 90-minute session for the IETF. We need to organize a side meeting focused on the architecture and management, on the architecture mostly, before our session. So that's work for me and you, Pascal. We started
And by the
for
way, you've sent
yes.
this email to Eric, actually saying that we are doing this and we are waiting for his answer. The way it usually works is as soon as they open, there are some meeting rooms which are open for this kind of activities, and they kind of open an agenda. And as soon as we see this agenda, I mean, first come, first serve, we jump into it and ask for our meeting. And we want this meeting to happen before the SCHC session. So as soon as we see that those rooms are open, we'll take the earliest meeting possible.
Just one thing, the sound was quite it was cutting. Is it only me, or is it on my side, or
I have no idea. I mean, normally I have a very good network, so I don't know what could be happening.
that sounds good. Okay, so it's on my side. Okay, so then sorry, continue.
Well, Marco has accepted to be shepherd for the SMPv6 compression. So Marco, thank you so much from everybody. So that's very nice of you to do this work. Submit an universal option. Has that been done? I think yes. I've seen it, right?
Yes, that was done. And basically all what the checkboxes. What was nice is that all of these were checked, and we also have Laurent that is going to be presenting today. Laurent and Samar, the quick compression. They published the doc on CoreConf, and basically there are two to-dos that remain. It's feedback on the IPsec diet protocol, and some work for you, Pascal. Resume the work
Yes,
on
I've been
protocol
looking at
numbers.
protocol numbers. I said I would, and I've been doing it. So I had to dig all these three, and I thought I had published an update, and actually I did not. So it was something being discussed, and I guess we did not finish the discussion. But the bottom line is the draft is kind of stalled. There was a discussion about removing UDP, and that's what I thought I had done. And maybe the discussion was not finished or what, and so I did not publish a revision with the UDP sections away. But basically, there was a very strong pushback to try and have a UDP header for compression. You can go back to the mailing list for that, but I guess it's very clear that we had to remove that, otherwise we would never pass. So the document will be just for an IP protocol number with INR and IEEE protocol number an ether type that we would get through the IEEE INR. And so, yes, what I did is dig history, and I think I sent a mail to Bob Moscovich because the document is still is. I hope we see Bob at the IETF to progress that, because I've not seen an answer to my request. So I don't know if Bob intends to finish the work or if I have to take it over. That's the piece I don't know. If Bob doesn't want to continue, I can finish it. I mean, it's a very small draft. It's mostly, checking with INR, and I guess it's through our INR that we can go to the IEEE INR.
Yes. Well, have you tried, maybe, yes, try contacting Bob and say, hey, well, let's meet in Madrid with Ayana and see if he shows up. And in any case, you can go and see them. And
at the IETF, INR has a desk, and we can go and talk to them. And so, ideally, we would go with Bob, but I'll see if I can grab Bob in Madrid. So that's where we are. Basically, the document is okay, but it has empty sections, and it's mostly about UDP. And UDP anyway will go away. That's pretty much where I stand.
Okay, perfect. So that's the yes. Go ahead, Pascal.
No, it's better that you do. I will just move the slides.
Yes, thank you. Yeah, so that's the so we as discussed last time, we made a request to Ayana for allocating a SID range as a SID registration for the SCHC data model, for the Yang data model. And yeah, we had a couple of back and forth with the expert that was assigned for this particular assignment. So there are 3 experts for this SID range, and it's Michel, Laurent, and me. So Laurent is submitter of the draft. So we can say, okay, we're not, maybe there is some conflict of interest here, I don't know, but in any case, Michel was the designated expert, and basically, so we submitted to have starting from SID 5000 with a size of 500 SIDs, and during discussion it was basically decided to say, well, no, we are not going to be fragmenting the SID space because these are numbers, it doesn't matter, round numbers and all that doesn't matter to machines. So just the next available slot is 2550 and 400. Why have a size of 500? Well, we had a lot of discussions, and then we compromised on 400, right, which seemed to be sufficient. So we have the SID range officially allocated on the IETF Yang SID range registry, and it is the one that is here, right? And the next step is to submit the actual SID file, which will have the actual allocation of each of the items in the Yang data model. So Laurent, if you can propose a SID file so that we can discuss that rapidly in the working group, and that we can submit that as well to Ayana for registration. Yes, Laurent?
Yes, sure, I will do that. One point that is very important is that we have a nice range. So now we have to use it correctly, and especially we will have evolution of the Young data model. We have revision. We have the revision of the co-op. We have revision also with universal options. So we have to assign them very carefully. So I will propose something, and I would like that the group discuss on this to forecast the evolution of the model to have something that is efficient in coding. Since we are dealing with deltas, it's very important to have the shortest delta as possible to have the shortest core representation.
Okay, so thank you very much, Laurent. And I think that was the last slide. Pascal, I'm not sure. Is there another slide? Maybe there's, yeah, just the state of the document. So there are two new documents that were submitted, and yeah. Yes, Laurent.
Yes, I tried to submit an update of IPv6 compression, and the system tells me that it's blocked. And so I have to see with data tracker why it's so bad with me.
Yes, please send an email to the data tracker because they are very reactive and they can help. You know, there seems to be some bug on your side. Okay, so my sound is pretty bad. I'll disconnect and reconnect right after. But you can, Pascal, you can take over and you know we can continue with the presentation. Yes, I'll be right back in a minute.
Yes, and I guess the next presentation is the quick compression, right? I don't have the agenda in front of me, but by memory, that's what it was. So let's go with this. Samar, I guess, is presenting. So Samar, I will propose you the to move. Do you prefer to move the slides yourself, or do you want me to move the slides for you?
Hello. Can you hear me clearly?
I'm sorry?
Can you hear me? Well,
I can hear you, but do you want to move the slides yourself,
yeah.
or do you want me?
Yeah, I think if I can do it, it would be better.
Yes, so I'm passing the control
Okay.
to you.
Thank you. I don't know if you can see the slides, because for me it's blank.
It's working. I mean, you've moved back and forth. It worked.
No, but on my screen it's just blank. I don't see anything. It doesn't seem to be working for me. I'm not sure why.
Samar, did you see the slides before that?
Yeah, I mean, yeah, before that it was fine. It just for me, I don't know if it's for everyone, but for me it's just blank. Like I can see the numbers for the slides, but the slides themselves are blank. So
we see the slides, but yeah.
That's interesting.
I can try to have something on the side. It's okay.
Okay,
If you can see.
Let me try something. Let me try something. Cool.
Do you see them now, Samar?
But it's okay. You can just do it as. Oh yeah, no, it's fine. Yes, thank you. It is okay now. Thank you.
Strange. Okay, so go ahead, Samar. You have 15 minutes.
Okay, so hello everyone. My name is Samar, and today I would like to talk about a proposal, a draft that we published recently, me along with Laurent, and with this draft we would like to talk about an architecture that we propose that could be used to possibly compress quick packets using SCHC. So this is just the presentation. First, I would like to start with the background if you're not very familiar with QUIC. So as you know, it is a transport protocol built on top of UDP, and it has some very nice features coming from TCP, TLS. It uses TLS 1.3 to have encryption by default. It has multiplexing capabilities similar to TCP. And it also uses connection IDs for allowing continuity across different IP addresses or port changes for a connection. And you can see on the right side, there's a typical quick packet. So it has a header. So each quick packet comprises of an outer. For this presentation, I might call it outer header sometimes. And this is the header of the quick packet itself. It might have some fields like spin bit, key phrase, or connection IDs, packet number, and so on. And then a quick packet might have one or more frames inside of it. And these frames can be of different types. For example, it can be a stream frame, which is shown in the image here. And these frames might also have a separate header. So I would refer to it as an inner header here, maybe. And there can be some different fields like the type, stream ID, and offset for this kind of stream frame. And then the data itself, the payload, is the stream data. And so the problem here is that although Quick is a very good protocol, because they spent a lot of time designing it, it is modern, secure, reliable, but there can be some overhead due to these header fields that the frames have, and also the outer quick packet header has. And this can introduce some problems, especially for bandwidth constrained environments, for example, deep space communication. And so with this proposal, we would like to tackle this problem statement of how can we minimize this footprint without sacrificing the core benefits, for example, the security benefits that Quick offers. And so for this one, in the proposal, we take a structured approach. First, the key idea here is to have two levels of compression in the Quick processing pipeline. One is the compression of the inner Quick frame headers. So the individual frames inside the Quick payload, we can compress them first, and then afterwards we can apply encryption because they're encrypted. And then afterwards we can also have a outer header compression for the packet header fields. And it is to be noted that these two levels of compression can be applied independently. So this is a compression flow diagram. You can see that we would start with some quick frames, which could be the data, for example, if you're watching YouTube. And these would be in, for example, stream frames. And then we would apply SCHC to it to compress the header fields of those frames. And at the end, we would have something like this called a stream compressed frames. And we can then aggregate them into in a SCHC packet. I mean, this is just here for what we call it in the draft. It doesn't necessarily represent a separate kind of type of packet. It's just what we call it here. So we can aggregate these compressed frames into an inner SCHC packet and have a rule ID perhaps at the beginning, which could have the set of rules that were applied to these frames, as well as it could also implicitly mention the structure of this packet. And then, like usual quick pipeline, we would apply the encryption. And on the side, we have the quick header, the outer header of the quick packet. We would apply the compression to that based on a different set of rules. We would have the compressed header, and then we apply the thing called header protection in Quick. I will talk about it shortly. And afterwards, we would have these two separate parts we combine, and we have the final compressed Quick packet. So, yeah, like I said before, the process is pretty straightforward. I mean, there are some challenges, of course, but yeah, the main idea is to just compress on two different levels. So apply to individual quick frames on the for the frames inside of the quick packet. So headers of those, there's a different kinds of frames. And then from there, we can have those compressed frames, we can aggregate them, and then have for example, the RID or rule ID for the frames, which identifies which rules are applied to those frames. And also it can define, for example, how many frames of what type this inner SCHC packet has. And optionally, there could be a length to define where this compressed inner frame ends and where the next one starts. to help with that, but it's optional. And so at the end, we apply encryption, and we have our compressed inner frame packet. Then afterwards, we have the outer quick header. So similarly for this, we have a set of rules we try to apply on some fields. For example, because there's different kinds of quick headers, we apply to, for example, the connection IDs, the packet number. We try to compress what we can. And afterwards, because in quick there is a thing called header protection, which kind of encrypts certain fields in the quick packet header, the outer header. So there's two options, of course. If we apply this header protection first, then we cannot really compress those fields because they would be encrypted. But with the mask, the other option is to compress first and then apply the header protection. But this could introduce some problems. Firstly, I mean, we would have the compressed fields, and in this second approach, we can add, similarly to the inner compressed packet, we can add a rule ID at the start to because we can apply header protection to that later on, so we can send it over the wire. And on the other side, it could already have the rule ID, so it knows which set of rules to apply for decompression of those header fields. But there are some problems, and to understand that, I would quickly just go over how the header protection works. So after we have the encrypted payload inside the quick packet, it takes a sample number of bytes, and using the header protection key, it creates a mask. And then, so in our this proposed architecture, we would have the compressed headers for the quick packet, and then we can apply that mask. Usually it would be to regular uncompressed fields, but in this case, we apply it to those compressed fields. And then at the end, we would have this outer compressed header as well as the encrypted inner SCHC packet. But in the standard header protection mechanism, firstly, it is mainly used to kind of protect the sensitive fields like packet numbers or packet number length and other bits of information. And yeah, it uses a mask to just XOR with these header fields. But in the original mechanism, it takes that sample from the payload based on an offset in which it assumes that the packet number is always 4 bytes in length. But because we could compress those fields, this offset might not work as it does in the original mechanism. And that is one of the implications of this kind of trying to compress the packet, the outer header of the packet, is that if we apply this header protection to the compressed residue, is the problem with the offset, because the packet number field could be compressed to just 1 byte and the other fields as well. And if we want to add this rule ID, then of course that rule ID also is variable length. So there's this problem of how can we calculate that offset and get the mask to apply and protect those header fields. This is one of the major problems or considerations that we need to really think about for this proposal. But of course, there's some other considerations as well. Like I said, there's 2 distinct contexts for the inner frames and for the outer packet header. So, and for it to for the compression to work efficiently, we would need perhaps dynamically updated context. For example, for the connection IDs, when we establish a connection, there's a set of IDs that both sides agree on. So if we can have those in the rules, then we can efficiently compress the connection ID field. And even to use this kind of compression, we could perhaps have a negotiation mechanism, which could be done using the transport parameters, but that is for later, I guess. And this inner compressed SCHC packet that I was talking about could perhaps be defined as a new type of quick frame, with those compressed frame aggregations. And of course, the actual benefits of this would need to be tested based on evaluations in simulated or real world environments. And just to showcase like how much we can actually save possibly using this kind of approach, we can take an example of this outer header. So version is almost always the same. It's 4 bytes. We can just have it in the rules. The connection IDs, like I said, if we can dynamically update the context on both sides to include those, we can completely elide those field or use a list matching. And that can save a lot of bytes, because in the RFC it is 8 to 255 bytes, but usually on average it's 8 to 20. And packet number for the same thing, it's usually 1 to 4 bytes, but we can perhaps using LSB compress it to 1 to 2. So overall, on average case, for different kind of headers, we can hope to achieve a compression of 22 to 46 for the long, or 10 to 22 bytes for the short header. Similarly for the frames as well, there's different kind of frames. For example, ping frame, there's only one field that it has, which is type, which is always the same. So it's like that. Stream, same thing. And so, yeah, here's it's just as an example, and based on what we see in the quick packets that you might capture in a quick connection, and the potential for compressing, being able to compress and save some bytes for these type of connections. And yeah, that is all on my side. Thank you for listening, and if there's any questions I would like to discuss further. Yes, thank you.
Thank you, Samar. That was really, really interesting and very well presented. Thank you so much for this.
Thank you.
I guess I take.
I think there's a question.
Anna, you have a question?
Yeah. Thank you for the presentation. I would like to ask you, how many stratums
Yes.
are you using?
How many stratums?
Hmm.
I'm sorry, I don't really understand what you mean by that.
You have the outer header and the inner header, and then I think
Yes.
that you have one stratum for the outer and one stratum for the inner. And
Yes.
my second question, if it's yes, my second question will be how your second stratum that manage the SCHC inner header will aggregate the different frames. Then you have different rules for each frame. How are you aggregating them in the same SCHC packet?
Okay, so firstly, yes, it would have 2 stratums in this case, as you explained. And for the inner quick frames, so firstly, it would be based on which frames can actually be compressed, like the headers of which frames, because of course not every frame could probably be compressed. So the ones that can, for those candidates, it could aggregate them. For example, in the rule ID, could specify the number of a type of frame, like a stream, acknowledgement, or ping, or any type. The aggregation is we didn't discuss a lot about it, but the aggregation, I would say, is mostly just based on the type of frames. And so, yes.
Samar, just to make sure there is a good understanding of the question from Anna about strata.
Yes.
I guess you use the same set of rules for every frame because you're compressing the frame header. but each time you're doing it on one particular header. So I guess
no,
you're not
because
using
those frames could have different values for the
Yes.
header fields.
So you do, if you have n frames, you do n times SCHC, if I can say it this way, right?
Yes, you could. I mean,
Once
yeah, if there's
per-
n frames that can be compressed, we could have those n set of rules in that context.
Okay, but I'm lost. I thought the rules would be the same, but what you compress is different. But the rules would be the same, no? The frame header is like the same format every time, isn't it?
Yes, the frame format is the same, and for many fields it would be the same as well. For example, a type of stream frame might have the same type for different ones, so it would have the same rule. But for some rules,
so you have one set of rules which can compress every frames, and you apply it n times if you have n frames, right?
Yes, I think, but those frames themselves in a single quick packet could have different values, so it could be.
Yeah, and you compress, yes, and so you can make different rules, each one that know only the values of frame A, frame B, frame C, or you could have one bigger rule which knows
yes, one bigger
how to
one, and
compress
then
frame A, frame B, frame C, right? So what is it you're doing?
I think it could be like one big rule, and then it could have more specific ones. Like it could first look at the big rule for certain fields, which could be the same for all the frames, and then the specific rule for example, a stream in a flow would have the same value for each stream frame in a quick packet. But something like a length or offset could be different. So
yeah, we've seen cases like that in the past already, having like a parent rule and rules being extended by more rules. Like there is a common thing and then specific things, and so you can build a rule set based on this parent plus the specific. But I don't know if we have really documented a structure for that, like a tree structure.
Laurent can explain it better because it was based on his idea of yes.
Okay, thank you, Sarah, for your nice presentation too. Yes, in fact, there is a start of possible solution in the ICMP v6 draft where we can compress, we can put a residue inside a residue. So here it will be, for example, if we have several frames, then we will put several residue together. So either you use current techniques and say that this residue has a variable size, and we use the current way to represent size in residue, or maybe we have to invent something better to be more efficient in that case. But for me, it can be viewed as an extension of what is proposed in ICMP v6.
Okay, so but to Samar, each time you apply SCHC, a rule set, even if it's the same or partially the same as the next, it's a different stratum. So you have as many strata as you get frames, I guess, plus as many strata as, well, there is only one for the header, so that will be n plus one, something like that. If I understand well what you're doing. But anyway, it's already 40 past the hour, so we have to move on. But we can continue this discussion in the mailing list and then at the meeting in Madrid.
Okay,
Thanks
thank you
so
for
much,
your explanation. Thank you.
And with this, the next is
yes, it's Mario. And yeah, given the time, I'm not sure we'll have time to finish the last the last presentation. So probably we'll have the core conf management document discussion next time. But we'll see. So
I can go very quickly, actually, but
no,
it depends if there are many questions or not.
No, because I think like there are 20 minutes, and I mean even the presentation of core conf management, and it also requires discussion and presentation and discussion. So it's better that we take the 20 minutes now to discuss, to see your presentation and your draft, and have the time to seriously see the next time Laurent's work. And Laurent says, take your time. So yes, you have 20 minutes for presentation and discussion.
Okay, great. So I am Marion Dumay. Hello, everyone. I'm going to present you a work started a few weeks ago on SCHC context lifecycle. Draft is just published a few days ago. So first, I would like to introduce the rationale behind this work. So as you all know, SCHC was initially designed and introduced for LP1s, for constrained networks. And so it was based on a common static context shared at the two ends of a communication. And so 2 years ago, this work group was concluded, and the SCHC group was started, and the scope of SCHC became broader. Sorry. And so we believe, well, obviously the context needs to evolve towards a more dynamic architecture, and more dynamic management, I'd say. And so this raises many challenges to go from static contexts towards more dynamic ones. And also, so the questions are, how do we install contexts and ensure that the contexts are synchronized at the different endpoints? How do we handle new protocols, and how do we use SCHC over different network types also? So starting this reflection, we started this draft with different objectives in mind, and so the main goal is laying the foundations of the future evolution of SCHC. But it's not very modest, but and so by reading the charter of the working group, we can see that it's very aligned, because it mentions that the working group should produce some documents on rule discovery and parameter negotiation, and also rule provisioning, maybe generic SCHC rules. And for the moment, I believe that we don't have much work on that for the moment. Okay, so the objective of the document are multiple. I'm going to present some of them just after. So the first work is to agree on terminology. It may seem kind of dumb, but by reading the different documents, sometimes the definitions are quite inconsistent. And so I believe that it's important to remind the definitions and to agree on them. The document also aims at identifying the interactions of the context with the other components when operating SCHC. Okay, and also the requirements for managing a dynamic context. And then the documents aims at describing the various stages of the context lifecycle, which is the title of the document, like how do you provision the context, how the context is can be modified, how to handle the context end of life, for example. And while doing all this work, of course, it's important to ensure consistency with other drafts, in particular SCHC architecture, and also core conf management. Okay, So I won't go into much details. This is about the terminology. I just mentioned the concepts that I give some definitions in the document. So, for example, for rule context and profile, fortunately, there is no inconsistency on those concepts. But the document gives quite new definitions for what is a SCHC instance manager, a session, the context manager, and also we introduced the notion of parser and also data model. So in the figure illustrates of these old and quite new concepts. Okay, I'm not going to discuss this right now because I have many things to present to you today. But please read the draft and don't hesitate to react on the mailing lists. Okay, so the next step was I don't know if you can see the figure clearly. The text is quite small. Okay, so the next step was to think about the interactions of the context with other SCHC components. This leads to the fact that in our approach, the Yang data models are at the cornerstone of future SCHC operations, in our opinion. The point is we want to go to we want further modularity in the SCHC ecosystem, in the SCHC operation. And for example, we could have different data models according to the different protocol headers that we want to compress. And we can combine all these data models with the SCHC rule data model to build some generic rules that we can further adapt according to the communication requirements. And the profile would evolve to maybe store all the references, the versions of the data models that are used in the communications in order to negotiate the parameters with the remote endpoints. And also, so we added the notion also of the parsing, of the parser. The parser that is used could be also indicated in the profile, because we've seen, for example, with CoAP, that the way the headers are parsed, are interpreted, may result in different rules that may be not able to that lead to different rules that cannot that are not interoperable. Sorry. So this is documented in the draft universal option. Okay, so that's it. Once we have this context and this profile with specific parameters for the communication, and I'm going to show you right after the handshake and stuff, the parameters negotiation, sorry. And once you have that at both ends of the communications, you can of course perform the rule matching and the compression. Okay, I hope this is clear. I'm sorry, I talk very fast. Okay, so just before focusing on the context provisioning, so this is the work we want to address in the document, to identify all the different stages of the context lifecycle in a dynamic environment. And so the questions we want to address are how a context is provisioned at both ends of the communication, how to make a context evolve over time. This was very interesting in your presentation, Samar. that we saw that for quick it is important that we can dynamically configure some target values and many. It is important to dynamically configure the rules. How to ensure when you modify a rule that the context keeps synchronized among the endpoints. How to detect and correct possible errors, or maybe just avoid errors, and how to manage the context end of life. So we suggested some stages. So this is in progress. First, provisioning. Next, activation, operation of SCHC with modifications of the context, and finally deactivation and retirements. For the moment, we only addressed in the document the first 2 points, the two first points, sorry, provisioning and activation, which occur quite at the same time. Okay, so those are just some ideas I put in the documents just to start the discussion on the context activation and provisioning. So we can imagine that this can we can have a handshake, just like we have in TCP, for example. So the first step consists in one of the endpoint sending an SCHC advertisement to the remote endpoint with maybe some SCHC preferences or capabilities, and then the other endpoint may reply with an acknowledgement and also some additional parameters to allow to fine-tune the context and the profile. And then the handshake is terminated with a final acknowledgement, and then the SCHC operation can start. You can see in yellow sort of loading procedure. This is where the provisioning happen, sort of. So this can happen before the handshake or during the handshake. So it can be, for example, retrieved from a remote location, or it can be sent from one endpoint to another. Well, so this is those are just suggestions, and feel free to react on the mailing list again. Okay, so that's it. There is a lot of work remaining, mainly structuring the document and add some details of each on each stage of the life cycle of the context, while ensuring the consistency with architecture and management drafts. And when it's more mature, I will be happy to discuss the status of the document. Okay, and your help is most welcome to contribute to the document. So please read the draft and send your comments. And thank you for listening.
Thank you very much, Marion. I mean, that's a very interesting work and much needed. We as you mentioned earlier, it's something that we know we have to do from like the start of this working group. So thanks so much for starting this work. And it's actually a lot of things that you have to cover. So I see your document more as an architecture already. So I don't know how it will match with I mean, what will stay as your document and what will have to move inside the architecture or be code in the architecture. But it's a huge piece of the architecture that's missing right now and that you have started. That's pretty much how I see it. Do we have questions?
Yes, of course. So thank you very much. Agreed, Pascal, with all that you said. So first, yes, thank you very much, Marion, and yes, that's a very big and very important work. So I was curious to understand. So you talk about, of course, the modification of the you have the stage of where where you can modify the context, and you provide like one way of how the SCHC context can be discovered. So do you think that there should be like more ways in which the SCHC context lifecycle could go? In the sense like, can it be something like, well, both devices have some baseline, some minimal SCHC context, and so then they can, in a peer-to-peer fashion, can, you know, bootstrap from this initial very basic profile, then, you know, add additional rules so like that it can evolve in this way. So I'm maybe talking too much, but does it fit with the way you're writing it right now, or do you think that there should be something new added?
Yeah, I believe that the handshake is just like one way of agreeing on the context and profile, and we can still have, for example, static contexts, and maybe just some kind of validation of verification that the contexts are the context match. And even using this procedure, you can actually have different variants, whether the context is preloaded on one of the endpoints, or maybe the endpoint has no context, and the context is sent by endpoint B according to maybe some preferences, or to the capabilities of the endpoint B. There are several possibilities actually, and in the documents, I think that it's important to have like maybe different use cases, and to detail different possibilities according to some use cases.
And if I understand correctly, you are open to suggestions, so if people can contribute these use cases, so
Of
that
course.
they can be included. Okay, thank you.
Okay, and also you mentioned, because I forgot to say that you also contributed to this work, as well as Laurent and Quentin. Thank you.
It's discussions. You wrote the draft, so you know discussions are. Everybody's discussing. You're the one doing the work. So.
And we also talked about like maybe relying on the other protocols handshakes to establish the context validation, or that there are several options actually that we need to explore.
Thank you, Laurent.
Yes, thank you for this document. It's a very good start. For me, maybe I'm one of the author, but I'm still in. I think what you show here is a very hard problem, because it's a little bit like a chicken egg problem, because you need SCHC to get the SCHC context, or do you think it's a totally different protocol? Because my concern is that we don't have any semantic and rule ID, so we never impose a size or a value in all the standards. So here, when you bootstrap, how can you be sure that it's viewed as a bootstrap and not a regular frame, I will say after? And if the endpoint A restart, how to be sure that the other knows that endpoint B knows that it has restarted. So for me, it's a very difficult problem, and I will be happy to discuss and find a solution for that.
Okay, yeah, thank you, Laurent. So there are many challenges, and the question of whether SCHC is needed or not to install the context is very problematic. So yeah, maybe for the context exchange between endpoints, we could use the management rules that could be like pre-installed or something. It's a different rule set from the specific communication context. Or we can imagine that the context could be retrieved with totally different protocols. I don't know. It would depend of of the use case, obviously. If it's a constrained node or
but if you have no rule at the beginning, you cannot use the management rule. So
that's for sure.
Okay, so the time is up for our meeting. I think Anna had some questions, but probably Anna, if you can maybe send them on the mailing list. So yes, thank you, Anna. So yes, thank you very much, Marion, for starting this work. I think it's going to be a long and important work for the working group. And with this, I think that it's all for today. Huge thanks again to Marco for taking all of the notes, or at least a lot of the notes. I didn't see if anyone else contributed, but thank you very much, Marco, again. With this, well, it's the end for today. Have a nice day and see you. I'm not sure if it's in 2 or 3 weeks' time. I need to double check. But in any case, see you like in 2 or 3 weeks' time. And if we have already our first slot for next time, please just send a slot request ahead of time, like if you want to present something. So thank you. Yes, Pascal.
The next SCHC is
Yes.
on this. I had it the 17th of June.
17th of June. Okay. So that's in 3 weeks. Yes, thank you. So we'll meet in 3 weeks' time. So yeah, don't like just send your slot requests ahead of time. Thank you all, and see you. Bye.
Thank you.